So let's take a look at some actual lenses and see what effects they have. So here's lens number one, and first I want to see it from the side. And it might be really tough to tell, but you should hopefully be able to see that it's a little thicker in the middle than it is on the edge. And so what sort of lens does that make it? Right, that's going to be a convex lens. If you can't tell that, if you were holding in your hand, what you would do is you would take your fingers, put them in the middle, and then draw it to the outer side. And so you should be able to see that it's thicker in the middle, thinner at the edge. You'd be able to feel that if you were holding it. Okay, so let's take a look at up close first, and you'll take a look at the image of me, and you can see that I'm pretty much the same size as usual. And then I bring it farther and farther away, and you can see that my image is getting larger and larger, right? We're getting something a magnified image. It's also upright. If it's upright for a single device, what's that telling you? That's telling you you're looking at a virtual image of my face right here, right? It's always upright, which means it's always virtual. Ooh, and it's always magnified in that case. Look at that, right? Okay. Let's take a look at something farther away. Like maybe those diplomas on my wall over there, right? So let me try it like this. Okay, so now if you're taking a look at those diplomas, let's get that through the lens. Here we go. Okay, so if I move it up or down, you should be able to see that the image of the diploma is going the other way. You see that, right? So if it's going the other way, what's that mean? That means it's inverted. Right? So if it's inverted, we're looking at a real image. And you should also be able to see that it is reduced. It's a smaller image, it's reduced, it's inverted, and it's all for a convex, a converging lens. Let's take a look at this one. This again, you should be able to see is thicker in the middle than it is on the edge. In fact, you should be able to see this is actually thicker compared to lens 1. So this is lens 2 and lens 1. Lens 1, lens 2. Lens 2 is even thicker in the middle than it's on the edge. All right, so let's take a look at my face through the lens. Okay, whoa. All right, so hopefully you should see very, very magnified, but also inverted. So if it's inverted, it's real. Let's bring it a little bit closer. Take a look. And so it's really, really large. Oh, there I am. Wow, look at that magnified image. But here, now it's upright, which means it's going to virtual. Think about this, right? So here I am closer, and you should see an upright image. This is when object distance is within the focal length, right? And that's where you get a virtual, upright, magnified image. But when you get farther away, now what's happening? Now when I move it up and down, you should see it's inverted. If I take a look at my degrees on the wall there, you see that? Wow, that's a really small image in the lens, right? It's going the wrong way. So it's inverted again. Here again, you can see there's my face inverted. So inverted, of course, is real. There's magnified. When it's going far away, it's reduced. Here's lens 3. Now this one, it's really tough to tell from the side because all you see is this thickness, right? And so if you really can't tell, many years ago I had a student who had an ingenious way of figuring out whether it's convex or concave. You put it on a flat surface, and if you can tilt it back and forth, that means that the thickest part must be in the center, it must be convex. This one here, I can't do that, which means all the outer parts are the thickest parts. This is a concave lens. Now, of course, if you were holding this in your fingers, you could put the lens in your hands and you could put your fingers in the middle, and you can see it's thinner in the middle. You feel it gets thicker towards the edge. This is a concave lens, which is a diverging lens. All right, so let's take a look here. You can see there's my upright virtual image, and it's always smaller. It's always reduced. No matter if I put it close up, it's only reduced a little bit there. Bring it farther away, it gets reduced, right? But it's not ever getting magnified. Look, it's going far away. Look at those degrees on the wall, and you can see they're upright, which means that they are virtual images, and they're reduced. No matter where I put it, it's always making a reduced image, because of course it's a diverging device, and diverging devices only ever do one thing: upright, virtual, reduced images.